Good day everyone, I'm Casey Jade Palamos and I'm going to report about attitude of beds. Attitude, a general term for the orientation of a line or plane. It refers to the three-dimensional orientation of planar and linear features such as bed, a joint, or a fold. Attitude of planar structures. The attitude of planar structures is defined by the strike and dip. Strike and dip describe the orientation of a plane in space. Strike is the bearing of a horizontal line on the plane, a scalar. Example is north 40 degree east. Dip is the inclination of the plane measured down. Dip is a vector. It gives the direction and amount of dip of the plane. Example for dip is 80 degree north. 80 degree is the amount and north is the direction. Attitude of linear structures. The attitude of linear structures is defined by the trend and plunge. Trend is the bearing of the line and plunge is the inclination. Trend is the direction of the line formed by the intersection of the planar feature with the ground surface. Trend is the same as strike only if the ground surface is parallel to the horizontal plane. Plunge is the vertical angle between the horizontal plane and the axis or line of maximum elongation of a feature. Plunge is measured along the axis of a fold, whereas dip is measured along the limbs. Linear structures are also defined by their pitch or rake on a given place. Pitch or rake, the acute between the line and the strike of the plane on which the line lies. Pitch is the angle between the axis of the feature and the strike of the plane containing the axis. Strike is the direction of a line formed by the intersection of the bedding plane with the horizontal plane. Strike in geology is the direction of the line formed by the intersection of a fault, bed, or other planar feature in the horizontal plane. Strike indicates the attitude or position of linear structural features such as faults, beds, joints, and folds. Dip direction. It is the direction along which a bed dips and is perpendicular to the strike line. The dip direction is the direction that a drop of water will flow down the plane. Dip. The dip of a bed is the angle between the bedding and horizontal plane. Example is the amount of inclination with respect to horizontal. Dip is the angle at which a planar feature is inclined to the horizontal plane. It is measured in a vertical plane perpendicular to the strike of the feature. Dip. The dip of bed is the angle between the bedding and horizontal plane. The amount of inclination with respect to horizontal. Here are the formula. HD is horizontal distance is equals to 1 unit. Vertical distance is equals to 1 unit. So vertical distance over horizontal distance is equals to tan D, or D is equals to tan negative V. Vertical distance is equals to horizontal distance. So here is the example of dipping sedimentary beds. There are two types of dip. First is true dip and apparent dip. True dip is the angle between a bed and a horizontal plane measured in a vertical plane lying at right angles to the strike of the bedding. It is the maximum vertical angle of an inclined structural plane. It is denoted by D. Apparent dip is the angle measured in any direction other than the true dip direction, so the amount is always less than the true dip. It is denoted by P. D is equals to true dip, P is equals to apparent dip, and alpha is equals to azimuth, angle between strike line and apparent dip direction. The relation between the apparent dip and true dip is expressed by the following equation. Tan apparent dip is equals to tan true dip sine azimuth. So dip and strike symbols. To further understand the attitude of beds, here are the examples. So in the figure, map or plan view versus cross-section view. The top black in this image is an area viewed in map view, which is the view from directly above the block. The lower block is from the same rock layers and you are viewing it in cross-section or from the side. Note that when you view the rock in cross-section, you can see how the rock layers are titled. To learn many of the concepts associated with structural geology, it is useful to look at the block diagrams and block models. Block diagrams are image based on three-dimensional. Block models, which are blocks of wood or paper with geological structures marked on them. Block models and block diagrams assist in visualizing how 3D geological structures in the real world can be represented in two dimensions on a map or in geological cross-section. As you examine the block diagrams in the figure in this section, note the different ways that you can view them from above or from the sides. If you look at a block from along the side, you are seeing the cross-section view. This is the view of geological structures. You also see when you drive through the mountains and the roads have been cut through the rocks, exposing structures in the rock that you wouldn't see otherwise. If you look at a block from directly above, you are looking at the map or plan view. Horizontal sedimentary layers viewed in cross-section. In this image, different types are given different colors. The oldest rock on the bottom is labeled number 1. The youngest rock in this image is number 4. So the wooden block in the figure, a cross-section view of sedimentary layers, provides an example of the principle of original horizontally and the law of superposition. Title rocks in block model. Each of the boundaries between the colored rock units in figure represents a geological contact, which is the planar surface between two adjacent rock units. Earth's rock layers are often complicated. Rock layers are often titled at an angle, not horizontal. This indicates that changes have occurred since deposition. Example, the rocks have been uplifted by tectonic activity and tidal. In the figure is a block model example of titled rocks, which color bed in the block model is the oldest. Given the law of superposition and the principle of original horizontality, it is more likely that the gray bed on the bottom left side of the block was the bottom bed during deposition, and therefore the oldest. In some circumstances, beds can be completely overturned. For example, in recumbent faults. If this was the case, the gray bed would be the youngest bed in figure. In the figure illustrates strike and dip for titled flat sedimentary layers. The line of strike is represented by the water line when a lake intersects with the rock along the shoreline. The dip angle for the beds is measured from the horizontal surface to the uppermost dipping bed, perpendicular to the strike line. Strike and dip for titled sedimentary beds. Water provides a horizontal surface. The strike and dip symbol is a T, with a long horizontal bar represents the strike direction, and the small tick mark indicating the dip direction. The dip angle is written next to the tick mark. So that is all for today. So thank you for watching, guys.